All right, 1314 is the packet I'm going over now, so take a look at your 1314. For example, number 3, I asked you guys about this yesterday. And some of you said you remember graphing these before with a number here. Some of you said maybe not. So, shall I do number 3 for you guys? Okay. Let's pretend for just a second that that 2 is not there. Can we do that for just a little bit? That 2 is not there. I'm actually going to cross mine out. I'm going to erase and put it back, so don't cross yours out. This would tell me to shift which direction? Translate. We've done that before. Right 1. Do you guys remember that? This would be right 1, and this would be up 2. All right, guys, if you're not going to be working with me, that's fine, but I need you working on the packet. You're not on your phone. You're not distracted. You're working on a packet. All right, does everyone agree it's right 1 and up 2? Yes? Okay, now the reason it's right 1 is because we don't show this anymore, but we used to do it with the sine and cosine graphs. Remember when we'd set it equal to 0 and solve?
Why'd you get rid of the 2 in front?
Just to explain what we used to do. And then you would add the 1 and x equals 1, and that's why we shifted to the right 1 and then up 2. Do you guys remember that from before? Yes? All right, same concept, but now with the 2. And again, we did this, it's been a while, but we did it with the sine and cosine graphing back in the first semester. We'd set the inside equal to 1, 2x minus 1. And we did that to figure out our right and left shift. If you remember that, if you look back in your notes, it's in there. We'd set the inside equal to 1, or equal to 0. So add and divide, what do we get? 1/2. That means you're moving how far to the right, because it came out positive. How far to the right? 1/2, which is actually smaller because the increments are weird. And then up how far? 2. Up 2. So over to 1/2 and up 2. And then what is your slope?
1/2.
1/2. So you go. And again, it's going to be wonky because of where the numbers are. But you're going to go up 1 over 2. And you could use the whole numbers here, up 1 over 2. So over 1 over 2. Up 1.
Should not use their scale.
Yeah, it's harder because of their scale, but you're going to go up 1 over 2 from this point right here because of the slope. Up 1 over 2. And because they're counting by 2's, you could still go up 1 over 2. So you could still go up 1 and then over 2.
That is so confusing.
I know. It is what it is. But it does come out like that. If you look at the back, right here, do you see where they went over? And this graph paper actually shows more grid. So I'm thinking this one had more grid. Maybe you just didn't copy out very nicely. But they went over 1/2 and then up 2. So you can see there, that's what they did. And up 1 over 2. Yep.
In absolute value, is that B?
Yes, absolute value. So you would not only go up 1 over 2 this way, you'd also go up 1 over 2 this way.
Could you just, like,
Yeah. So if you, yeah. Which one? 4. Okay, graph this function, label the x-intercepts, E and F, and maximum value of the function at point G. Okay, first off, what shape is this and why? Parabola. Okay, because of the x squared, it's quadratic, it's a parabola. 2 choices you have to graph this. Well, actually, they told us to use x-intercepts, so we could do that. Let's do that. Y equals, I'm going to factor out the negative, And typically, I wouldn't use x-intercepts unless they asked. And since they asked, that's what if I have to find them, then I'm going to use that method. Okay, and I jumped the gun there. Let me just factor out the negative first. When I factor out the negative, what do I get?
X squared minus x minus 6.
X squared minus x minus 6. And then double bubble. Plus minus, and what is it? 2 and 3. Plus 2 minus 3.
Yeah.
That negative doesn't do anything as far as my x-intercepts because I've already factored it out. It's not part of my x-intercepts. So what are my two x-intercepts?
Negative 2.
-2 and +3. Okay, do you agree with that? Okay. Again, this one's not going to come out the nicest because of fractions, but what do we know about, they asked us to label the x-intercepts, which we've done. They asked us to label them E and F, and they asked us to label the maximum value point G. Okay, what do we know about the maximum value on any parabola, any maximum or minimum? What's another word for it? Or the maximum. Okay, the maximum value is the y value of your what? What's that point right there called? It has a special name of our parabola. Starts with the V.
Vertex.
Vertex. Okay. The maximum value. The maximum is equivalent to the vertex. What do you know about the vertex? The vertex lies on the what? Axis of symmetry. Do you guys all agree with that? If I know the x-intercepts, let's pretend that these were the x-intercepts. What do we know about the axis of symmetry? It's right in the middle. So you can count, which is a little harder here because of the counting by twos, or you can add them and cut in half. So count your way to the middle, which is a little harder, or add your x-intercepts, 3 plus -2, and cut them in half. What's 3 plus -2? Cut in half? So 0.5. So your axis of symmetry is 0.5. So it's really, again, not the best number line to use. And then if the vertex always lies on the axis of symmetry, you guys did this in math too, by the way, because my kids just tested on this. If your vertex is on the axis of symmetry, and we know the axis of symmetry is 1/2, what can I do with the 1/2 in this function to find the y value? Plug it in. Do you guys agree x equals 1/2? This is the x equals 1/2 right here. And if I plug it in, I can find the corresponding y value. Yes? Y equals negative parentheses squared plus parentheses plus 6. And I don't know why they do this to you on the Sbac, but they throw these fractions in. I guess they figure you guys are old enough, you can handle it. What did we say we're going to plug in?
Yeah.
1/2. 1/2. What's 1/2 squared?
4.
So negative 1/4, right? Because it's the opposite.
Why?
Because it's the opposite of 1/2 squared.
Could you distribute the negative at the end? Like keep it in like the bigger parentheses and
Oh, you want to plug it in over here?
could you?
Yeah, you want to plug it in there instead?
Yeah.
Okay, so I'm going to scratch this. Y equals negative parentheses, parentheses, and then 1/2 plus 2 and 1/2 minus 3. Okay, what's 1/2 plus 2? 2.5. Can we change that to, because we're going to have to multiply later. 2.5 is what when you multiply and add? 5 over 2. And don't forget the negative still out there. 1/2 minus 3. Think of 3 minus 1/2. If you have 3 whole items and you take away half of one, you're left with what? 2.5. And positive or negative? Negative. And I guess I could have left this one and just changed it at the end. So this was 2.5. Okay, so you said that was 5/2. 2.5 becomes what? What's going to happen with these two negatives? Okay, and you said it becomes what? 5/2.
Well, wouldn't the negative make the 5/2 negative and then the second 5/2 positive? So at the end it would still be negative.
Say it again.
Like when you distribute the negative to the 2.5.
This negative doesn't get distributed to both of them.
Oh, why not?
Because it's like -2 times 3 times 5. When you multiply two positives and one negative, it's not distributing to everything. It's just the first term happens to be negative.
Pulled it out at the beginning.
Even if you pull it out, you do 2 times 3 times 5 and take the opposite of that. So let's take this out. I'm going to leave this out and put that back in. Covering that out, what's 5 times -5?
-25.
Over 4, and then you're still taking the opposite, so it becomes
That would make sense.
positive. So what's 25 divided by 4? Can you calculate that?
6.25.
6.25. So you're going to go right 1/2. So the vertex is right 1/2. We got that from adding and dividing by 2. And then we plugged it in and got 6.25. So 6.25. And that they asked us to label G. And is it opening down the way it should because it's negative?
Yeah.
Yes. So if they asked you what is the maximum value is the 6.25. It's the Y value of your vertex. Make sense? Yeah, and if you look here, oh, they did label it. So 3, 0, -2, 0, 0.5, and 6.25. So it did work. Okay. All right. Any others from 13?
Yeah. Would you do 6, 7, 10?
6, 7, 10? All right. Do you guys remember first what the cube root function looks like? This is the x cubed. The cube root was do you guys remember your Egyptian one you had last year? Do you guys remember that?
I mean, I recognize it, but I
No.
don't know how to do it.
We did it in this class. We did the inverse functions. It looked like this. No? Okay, so this shifts you which way? Right one?
Yes.
Yes. And then, right one. And then up how far?
2.
2. So the cubic function looks like this. I move it and I just, yeah. Yeah. So I just flip my paper to make the cubic function. Like I think of it here, and then I flip it and do it there.
You treat a root kind of like a absolute value.
What do you mean?
Like when you're finding the shift.
Yes. The shift works on absolute values, on parabolas, on square roots, on sine and cosine functions. They all work that way. So this would be left 4, down 1. And that would just be the regular square root function.
What is square root function?
Half of a sideways parabola, so it looks like that. I mean, I drew it at a random spot, but it's, so it would go left 4, down 1, 2, 4, down, left 4, down 1, and it's positive, so it's the right top. Where did I go? Right here? So it looks like that.
Y-intercept, would you just plug in 0 for x?
Yes. X-intercept, for the x-intercept, you would plug in 0 for y, and then for the y-intercept, you'd plug in 0 for x. Yep. All right. And what was the other one?
7 and 10.
7, and 10. And I want to go back and fix this one really quick. It is like this, but it's the other way. So I'm still going to do it sideways, but it looks like this. All right, so write 1 up 2, and then you do your sideways cubic function. Okay. Ooh, excuse me. Number 7. Do you guys remember piecewise graphs? I did not do them this year, at least I don't think I did. Did I? No, you guys did them last year, though. All right. When I graph mine, I break them up. -1, and again, I hate this number line. -1, and I'm just going to put dots for now. -1 to +1, which is a really, really small. Are you guys okay if I do it on a separate piece of graph paper? All right, so they gave us when x is less than -1, when x is between -1 and +1, and then when x is bigger than 1. So there's 3 pieces. The first one is the far left when x is less than -1. The middle piece is the middle piece here where x is sandwiched between -1 and 1. And then the far right is this last one is the far right where x is bigger than 1. Okay, now what I suggest you do is plug this in for x. So you would do -2 times -1 plus 5. What would that give you? 2 plus 5 is 7. So -1 comma 7. 1, 2, 3, 4, 5, 6, 7. So again, it's not drawn a scale, but that's okay. -1, 7, open or closed? Open. Okay. You have choices to graph the rest. You can use your slope is -2 over 1, or you can just plug in, say, -2 or -3 to figure out what your other point is going to be. What would you want to do? I don't know. Do you get what I'm saying? You can use your slope to figure out your line. It's negative slope. So would my graph be going like this or like this? First or second? If it's negative, so it would be the first, right? Because it has to be negative slope. So you would go up 2 over 1. And it doesn't really, I mean, it's not that big of a deal as long as it's negative slope. Okay? And then we already know that point there. So -1 is not 7. -1 and then +1. And you plug it into this new function right here. Can we do that together? What's -1 squared? 1 times 3 plus 4.
7.
Okay. Does it work the same for +1? +1 squared? Okay. -1 up 7, +1 up 7. Now, yes, so this one is, there's an equal bar. So once where it was open, it now does what? And is that okay if you put a closed dot on top of an open dot? As long as there's not 2 closed dots. And then this one also has an equal bar, so this one is also closed. Now typically you would connect these 2 lines if it was linear. Is this a linear graph? Where are we at? This right here. No, what is it? Parabola that's been shifted up how far?
4.
So there's your parabola there.
So you went down.
I went from the origin,
okay.
I went up 4 because it says +4 right there. All right, and the last one, you plug in what? What's this number right here? 1. 1 squared
1.
times -4,
-4.
and then -4 plus 11. 7.
7.
Now, I end up back on this dot. Is that bad if this one's open? No, because I'm just putting an open circle on top of a closed circle, so that's okay. Right? Okay, it is a parabola opening which way? Down. Which way is it shifting, actually? Is this shifting up 11? 7, 8, 9, 10, 11. So, it's doing something like, but we're not graphing this piece, so down like this, but it's U-shaped. So if you can imagine all of this being the parabola, but we're only graphing this piece because it says when x is greater than 1. Do you guys remember doing those last year?
Yeah.
Were they hard, easy? They were what?
Easy.
They were easy?
But I forgot how to do them.
Okay, that's fine. What number was this? 7?
Yeah.
And they ask us to label points. Okay, so -2, what function would you plug it into? The top, middle, or bottom? The -2 is over here on the far left. So is -2 between -1 and 1 bigger than 1 or smaller than -1? So you'd plug it in here, right? So what's -2 times 2? -4 plus 5? And I set the wrong number. No, I did not. Okay. What did you get? 1, and that's not working. -2. That's negative slope. Oh. Okay, do it again. Negative, we said -2. -2 times -2?
4.
4. And 4 plus 5?
1.
9. Okay, 7, 8, 9, so it's like around here. And then, what was the other point they want us to plug in? -1. -1 is which one? Because it's equal to -1, so first, the top or middle?
Middle.
Middle, so plug in, did we already do that?
Yeah.
Right here. Okay, 0, 0's where? Top, middle, or bottom?
Middle.
Middle. 0 plus 4 is, did we already have that one labeled as well? And then 2, which one would we plug it into?
The last one.
The last one. 2 squared?
4.
4 times -4.
-16.
-16 plus 11?
-5.
-5. So that was 4, 2, so it would go further down. What'd you guys get?
-5.
1, 2, 3, 4, 5. So it would just be a little more narrow than I had. All right, but we know it's curvy. We know it's not straight because it is a quadratic. It is a parabola. All right, any others? 10. Are you guys ready for me to move this? Number 10, graph this function. This is a function that you haven't learned yet unless you graphed it last year. Did you guys graph logs last year? Okay.
I think we did.
Y equals, give me an exponential. Y equals 2 to the x. Yeah, is that one you guys have done before? Yes? Exponential. Do you guys remember that? Okay, so logs and exponents are inverses of each other. Do you remember the inverse unit that we did where we talked about it reflective across the y equals x line? Do you guys remember that?
Yeah.
Yes, it was back, was it first semester or was it second?
First.
Nope. Don't remember.
I think it was second, which means it will come up on our final.
Oh, God.
Yeah. We did a whole unit where we talked about the graphs being, it might have been our first unit. Let's see if I can find it. Our first unit of second semester is what, is what I meant.
You sure it wasn't
Or
our last year?
maybe 8, maybe not our first, but our second. Let me, maybe our next. Maybe we didn't do it in this class.
I just did.
Oh, I know we did it.
Yeah, we did.
Yeah, I just don't remember which unit it was, but we did inverse functions.
Yeah, I mean, we did, I just kind of think
Okay, it's in there somewhere. But we talked about, so if this was 0, 1, this point, remember we talked about the x and the y flipping, this would be 1, 0. And you see how this x-axis is the asymptote. It's going to look something like
So just be the opposite.
that.
How would the 2 impact that?
It just, like a parabola, it makes it increase at a faster rate, so it's shooting up faster, like wider, thinner type stuff. So this is log base 2 of x. So that's how log functions change. Log functions are inverse functions of exponential. So, do you remember when you did these and then you shifted, this was like your key point that you shifted up, down, right, left? This is going to be our key point, the 1, 0. So, here's the 1, 0. Which way is it shifting? Left 4, 1, 2, 3, 4. So it's at what? That'd be -3, because if I was at the 1 and I went 1, 2, 3, 4, it's at -3, 0. And then it's, you see here at the 1 unit away, this 0 is the asymptote where it gets really close. Do you see that? So the same thing here. So this one here is going to be your asymptote now. And it's going to look like that. So if you can just remember, because this unit won't come up until after the Sbac, it's probably the only thing on there that we haven't, that you won't know or haven't seen, unless you did it last year and you guys don't remember.
Yeah.
Did you?
Yeah. Well, I mean, we did logs, but I was absent.
Why did you start at 1?
That entire unit. So.
Okay. What was that?
Why did you start at 1?
Originally, because exponentials start at 0, 1, which means the inverse will start at 1, 0. Because we flip-flop them, and then from the 1, 0 we went left 1,
Oh, okay.
2, 3, 4, which would be at -3. And then I just put a dotted line there and did that. Yeah? Okay. Any others? Okay. What section was that I just went over? Okay, so 14. Any questions from 14? Or do you want to save that for another day since the bell's about to ring? Save it? Oh. 3 minutes? 4 minutes?
Yeah.